And we are live, hopefully with no echo this time. I double checked. So, what should we talk about this evening? You want to talk the NFL, baseball? You know, the Mets are actually playing well lately. We could talk about, a hurricane. You don't say. Yeah, there's been a lot of interesting posts of lately on social media and everywhere else about Hurricane Lee. Now, we're going to talk about all the potential impacts. What are the factors evolving with this hurricane and what we need to watch out for? What's reality? What isn't? Why the models are doing what they're doing? And also look at the actual current structure of the storm to get a pretty good idea. And at the same time, also look at the overall pattern that is starting to develop that is going to play a key role in the whole setup of not only the track of Lee, but also the impacts for the next couple of weeks of our weather pattern here in the northern mid-Atlantic. So we have a lot to cover, and I'm seeing that we have a pretty good audience here that is here. So good evening, everyone. We are also live on, of course, YouTube, and of course on X. I always forget X marks the spot. There we go. So we are on X, and of course, if you're interested in following other social media, we're also on what is it called? LinkedIn and oh yeah, TikTok. That too, right? So where should we start? Right? There's so much to really study here. So I guess we'll start off with the actual particulars that we have right now in place. Okay, Hurricane Lee has winds of 75 miles per hour. This is as of 5 p.m. It's moving to the west-northwest around 14 miles per hour. Let's pull up the public advisory here. And you can see it has a pressure of 991 millibars, which is pretty impressive too. Let's take a look at the satellite picture here. Let's see, at least it should be this one. Okay, so when I look at this storm, what do I see? I see a lot of potential here. So the first thing you want to do when you're forecasting a tropical system is actually get an idea of what we have in terms of the warm core low. You can look at model guidance all day and look at trends and this and that, but what are we really dealing with here? Okay. And what stands out to me, first and foremost, is the upper level structure of this storm. Why does that matter to me? Well, think of a warm core low like an engine, right? And this engine's picking up all this warm water from the tropical Atlantic, lifting it up in the atmosphere. That's why our cloud tops are so cold. And rapidly expelling that latent heat. Well, a hurricane intensifies by the ability of getting rid of that latent heat to expel it, exhaust it. So think of it like your car. If your car has a good exhaust system, it's going to be able to really power up and utilize the most of the engine's potential. If you have a clogged up exhaust system, it's not going to do so well, right? The engine's going to kind of choke. It's going to be a little bit of feedback. It's not going to be able to reach its full potential. What I'm seeing tonight here is a very nice, well-established anticyclonic circulation. I don't see much in the way of any type of significant shear. There's a little bit of a northeasterly shear component that's starting to go away. But the upper level components here, you can see it fanning out. See this fanning out here? Very nice depiction here. And you can see it also really well in the water vapor satellite picture. Look at this expansion that's going on here. So why is this important to me? Well, this expansion, this transport of latent heat energy being pulled, sent away from the core of the hurricane, it builds up height somewhere else. And for every reaction, there's an equal and opposite reaction. And that's really important to this forecast because what we have to monitor here is as this storm intensifies and organizes, and there is a ton of warm water for this storm to feed on, How will it start to influence the high pressure system to the north of the storm? And that is the question that the model guidance is struggling with. How do the transport of mass balance itself out with another change that's happening in the atmosphere? And for that, let's go to our other favorite map. Let's see here. I think it's this one. Ah, yes, perfect pick. Okay. Now we have to go back to the Pacific. Now, this is at 250 millibars. So why am I showing you this? This is the other factor that is controlling this whole pattern. You see, right now, we are shifting back to a trough in the Aleutians. We started to see this pattern starting to return. For a while, we had a ridge that led to a trough in the west, ridge in the east, and it's been hot and humid, really uncomfortable, miserable. That is coming to an end. It's starting to come to an end with our trough, with our ridge in the east starting to get pushed off the coast and weakening, and a new trough starting to establish itself. While that's all happening, you're having individual short waves starting to develop in this trough that will start to dive into the eastern 2/3 of the United States. And this is where part 2 gets really tricky. And for that, let's take a look at the model guidance here. Now, you know what? First, we'll start off with the GFS 18Z. Why? Because I got a ton of requests about that. So let's talk about that for a moment. With our storm, there's our ridge influence that we have to watch out for. See that balance there? Now, what the 18Z GFS does, GFS ensembles, is that it builds up that ridge and it allows the storm to track northward. Notice the trough here is more of a neutral tilt, so you get more of a northerly component. In the GFS guidance, and we're looking at 500 millibars for a reason, because what I want to do is illustrate the interaction between this low and this ridge, and how the strength of this ridge will allow Lee to track further west, but also the interaction of this trough is going to matter. So while this is happening, and you see this intensification and the ridge remaining in place, what creates a lot of havoc here is that there's other tropical systems in the central Atlantic that could try to cut down on this ridge. So the reason why we're seeing some volatility here and whether or not it'll get close enough to the coast is because you have a lot of these competing actions all occurring at the same time. While that's happening, you have this trough. But notice on the GFS, it's a positively tilted trough. Look at the winds coming in from the southwest. That's why this low gets kicked out. How about other model guns? Well, let's take a look at the European. I want to show you this because this isn't normally what I do, like going through every model, but it's an important exercise just to show you what is driving these different solutions. So rather than getting caught up in someone posting a surface map and screaming on TikTok or Twitter or Facebook, you're going to understand why they're producing these different solutions. So the further west solutions are all driven by the idea of a stronger ridge here. If the ridge gets knocked out a little bit faster because of another tropical system, because it's trying to balance out all these different mass differences, then this storm's going to be able to exit out faster. If the ridge remains strong because we have a Cat 4 or 5 hurricane here, which is very much possible, then the storm is able to push further west. But there's a limit. The reason why there's a limit is because of this trough axis here. You see this positively tilt? That supports southwest to northeasterly wind. So the storm has to get kicked out. And that's why you're seeing that. Now, the one warning sign, and we saw this with the 0Z European, is this. And the reason why I'm concerned about this, let me pull up a different map here. Let's see here. I want to pull up winds. Here we are. Okay. The reason why that solution has me slightly concerned from 0Z last night is if we get an upper level low cut off here around the Tennessee River Valley. And I've been warning about this going back to like May. I don't think it's going to happen, but if there's going to be an impact on the coastal plain in the New York City and Philadelphia metropolitan areas, what you're going to have to develop here is some sort of cutoff low to produce a neutral to negatively tilted trough to pull this storm to the west. The 0Z European guidance showed that solution. I'm not saying it's right. I'm saying this is what would have to happen to get a more westward solution. And the reason why you would need that is that what happens if you set up this solution, let me see if I can zoom in a little bit further. Okay. What happens when you set up the solution is that you have your block here. So you know your storm is going north. It can't go northeast just yet. When this starts to cut off in this nature, the polar jet stream kind of leaves this behind. And it opens up the potential for the storm to push towards the coast. If this doesn't develop, it does the 12Z instead. Let's go to that solution. In the 12Z solution, the trough remains connected. So you can see your southwesterly flow all the way through. And so instead of the storm trying to bend back to the west, you can see that connection of being forced out. Okay? This is why this feature is very important. And this is kind of the wild card. And it all connects back to what's happening in the Pacific. The evolution of the trough around the Aleutians is going to set up several short waves diving in. If one of those short waves ends up being a little bit stronger than what's currently forecasted, it could in theory cut off into an upper level low, like last night's 0Z European was showing. If that happens, then you open up the potential of an avenue, a weakness in the pattern that supports some sort of impact on the mid-Atlantic. Overall, though, all model guidance basically supports a solution where that doesn't happen. So the European ensemble guidance, for example, doesn't feature that solution at all. It keeps our trough into a positive tilt and kicks this puppy right out. So what I'm trying to show you are the different options and what we're going to be looking for. Not going to show you the worst case solution, pull up the UK MAT, the CCM, all these other models, okay? What you basically have to study here and what we're basically watching is two features. The evolution of the long wave 500 millibar pattern over the eastern United States, driven by the trough that's starting to develop in the Aleutians around the Gulf of Alaska, that teleconnects a trough and short waves diving in that will translate to periods of rain for us at the end of our hot and humid pattern, which I'll show in just a moment. While that's happening, the hurricane intensifies, reaches category 4 or 5 status, which looks like it's highly likely. That helps to build up the ridge to the north of it, which supports a westward track for some time. Eventually, it must turn north because you have a trough in the east and a ridge over the central Atlantic. That is the avenue to track this somewhere between Bermuda and the East Coast. So to determine just how far west, what we're going to be watching for is that ridge and the orientation of the trough. If you have a positively tilted trough and the ridge is getting to, let's say, about Bermuda, then guess what? This is missing us and it's no big deal except for some beach erosion and some really strong riptides and some pretty impressive waves hitting the shoreline. But if you get any type of cutoff low and that ridge extends beyond Bermuda and allows our storm track to get closer towards, let's say, the North Carolina coastal waters, everyone in New England and the northern mid-Atlantic are going to have to watch out. When will we learn that what we're actually dealing with? Probably at the 120 hours. So basically, I'd say Monday. Monday is when we'll actually get an idea. And then by the time we do our next live chat, we'll be talking about basically either the storm being a threat for us or getting kicked out. But that is pretty much the bottom line. And think about this. We have a long way to go here. We got, about a 10-day period of watching this storm evolve and set up. So, again, we have a long way to go. But these are the things I'm watching for. We're not looking at different models, model trends, or anything of that nature. What we're simply watching right now is the evolution of the pattern and the evolution of this storm. So I like the idea of a major hurricane developing out of this. A nice central dense overcast, nice setup here with the outflow here. Everything that I would look for as a meteorologist for an intensifying hurricane is standing out here for me. I got very cold cloud tops. In fact, here, I got an idea. Let's see if we can see any lightning out of this. Flash density. Let's see. Let's see if we have anything of interest here. Okay, so we're starting to see a lot of lightning out here, a few sparks here, not a lot in the central dense overcast. Sometimes when you see a lot of lightning, it really shows up of a developing eye wall, but so far we haven't seen that evolution just yet. But certainly some pretty cold cloud tops here, a lot of indication. And some of the coldest cloud tops we've seen with this storm, we're talking about minus 80 degrees Celsius. To understand why that's important, the colder the cloud top, the stronger the lifting. So what's basically happening here is that the water vapor is getting lifted up into the atmosphere. And as it's getting lifted up into the atmosphere, it's getting into a colder and colder environment. And so that colder environment allows for the water vapor to condense and produce these clouds. So that tells us we have very strong lifting evolving as a result. So this is happening right around the low level center. So this is telling us that this warm core low is developing pretty well. Now, while all that is happening, we got our pattern evolution sitting up right over us. And we'll reassign back to our world around the northern mid-Atlantic. And yeah, it's been hot and humid. It's been uncomfortable, and I've hated it. But the good news is that it is on the way out. The ridge axis is passing over us. Another muggy evening, but generally quiet. 500 millibar heights are going to start to fall as this ridge axis exits. Now, one thing that was a little bit unexpected in this whole pattern evolution was this upper level low that just kind of sat and spin. What is this part of? Well, this used to be part of Idalia. Yeah, it just kind of hung around, spun around. It produced a few unexpected showers. What was it, on Sunday? And also on Saturday. And I did not enjoy it. It produced lightning and thunder, and I had to do more work. Not cool. But it was a very important lesson. It was a lesson that this upper level low was something to be contended with. So it's kind of slowed down the pattern a little bit. But now it's starting to exit, and this ridge is starting to exit, and now we're starting to get our new 500 millibar pattern. So let me zoom out here on this. And you can start to see here at the mid-levels that trough starting to take shape. At 500 millibars, the trough starting to take shape. It's not established yet. We're at the start here. Understand what's happening here. The change in the Pacific is starting to happen. And so as a response to that, we're getting a little bit deeper trough taking shape here. And as a result of that, our cold air transport is just starting to get organized. And our influence from the polar regions is just starting to get itself together. So while that's happening, the pattern's evolving, and we're seeing the development of showers and thunderstorms. And let me refresh this real fast. Of course, this is from WeatherTap if you guys want to know where this data comes from. So, what we're seeing here is as the 500 millibar heights are falling, we're getting these little prefrontal troughs here. The first one's going to impact the region tomorrow with a few widely scattered showers. But the key thing to remember here, if I could pull up the right map, here we are, is all the moisture that is in the atmosphere. So with precipitate water values ranging, let's see if we can zoom in on this, ranging from about 1.3 to 2 inches, that's going to support the potential for some very heavy downpours with each one of these showers. Not a widespread event, but as you can see, the 500 millibar heights falling here. See it very nicely in the European guidance here. Notice the trough and orientation here is neutral to slightly positive tilt, which means our cold front's going to stall out over here. And what you're going to end up with starting tomorrow afternoon and continuing all the way on through the weekend, these scattered showers. Why is that important to us for the whole evolution of the pattern? Well, the front's going to stall out. You're going to get these little waves of low pressure and your trough orientation is going to develop. In the meantime, there's our little trough that we're going to be watching for this. So what I'm going to be watching out for is as this trough starts to develop, what type of orientation does it really start to adapt? Is it a neutral tilt, which is north to south, or is it positive tilt, southwest to northeast? The more positive tilt that we have this trough this weekend, the better potential we have this remaining a positive tilt and kicking Lee out of here. In the meantime, we're going to be dealing with scattered showers and a few thunderstorms through this weekend. If you're going to the Giants game, the Jets game, the Eagles game, I think they play home. I don't know if they play in New England. I have to check that. But even in New England, there's going to be scattered showers and thunderstorms throughout this entire weekend. Not a washout, but certainly some of these thunderstorms are going to be a bit of a pest with some very heavy downpours, tropical downpours. So it's going to be kind of hit and miss. If you get hit, you're looking at about an inch of rain. If you don't get hit, maybe a tenth if that. So it's going to be a bit spotty, but there's definitely going to be a lot of unsettled conditions through the weekend with cooler air slowly pressing in. So this isn't going to be a quick snap from hot to cool, but it's going to be a step down with the stationary front and then cold fronts coming in behind it, reinforcing it. The stronger those cold fronts get pushing in, the more likely Lee gets kicked out, because it tells me that the trough is in positive tilt. The cold front is stalled out. The cold fronts come in, they stall out. The cold air starts to get reinforced, and Lee gets kicked out. So we're going to be learning a lot over the next 5 to 7 days. So my objective for tonight is to remove the scare tactics and the hype and all the nonsense. And that's essentially what's going on with our weather pattern. So with that, I am going to dive into all the questions first, of course, in the premium chat. As you know, premium members get all of their questions answered to the best of my ability. So if you're interested in becoming a premium member, right now it's only $11 a month. By November 1st, we'll be increasing our prices to $15 a month. But if you subscribe now, you lock into the current price. Definitely check that out. It's definitely worthwhile as we head into what should be a very interesting winter. So let's see what we have here. Let's see. Good evening, everyone. Good, everything's working. And of course, Snowball starts with snow. Not this time, but I understand the idea. An expectation that Lee will enhance a 500 millibar pattern, or will it be absorbed with negligible impact? That's a great question after the storm develops. Okay, so here's the idea here. And let me go out here. Okay. So, if Lee intensifies into a Category 5 hurricane while lifting to north of Bermuda, That's going to increase the potential of influencing the 500 millibar pattern in the northern Atlantic. Now, the wild card here is whether it interacts with the polar jet stream initially on the east coast, with that positively tilted trough ending up being more of a negatively tilted trough, which would then entail lead to a much deeper trough over the eastern United States and pull polar air in from Canada, which would create a vastly different weather pattern, and it would adjust the long range pattern. Right now, we're not seeing that. Right now, what we have is a positively tilted trough. The hurricane gets kicked off into the northern Atlantic and weakens, enhances the development of the 500 millibar pattern in the northern Atlantic, possibly a brief negative NAO pattern, but the pattern overall isn't at the state to support sustained high latitude blocking because it's still in a period of change. So there's a lot of moving parts here, so it's really hard to lock into anything. But if you get an interaction with the trough over the mid-Atlantic at the peak of the intensity of the storm, that would be a totally different game changer. Right now, that's not expected, but it's something that we're definitely going to be keeping an eye on. The 700 millibar level has cooled off a lot, and it's below freezing over pretty much all of North America, Northern Asia at that level, and 850 millibars cooling as well. Yeah, I've definitely noticed that the evolution of the polar vortex at all levels is pretty much on track, nothing too unusual. Definitely notice a building up of polar air masses in Siberia and Northern Asia, which should start to help to enhance our snow growth, which I'm going to start keeping an eye on starting probably this week, probably with a discussion tomorrow on that and keeping an eye on that and seeing how that evolves. That's going to be an important factor in the evolution of our weather pattern and our look at what we could expect for winter, which again will probably be coming out with a discussion in late October. I'll have a date once I get more data. Very impressed by the shear from the Philippines to the Pacific all the way through the Indian Ocean with strong easterly flow at 250 millibars. Yeah, that's typical of El Nino. Definitely, that is certainly a factor. We should see that return to the Atlantic pretty soon, but right now we're at our peak and we have plenty of activity still underway. SPC enhanced risk was severe for a lot of the Mid-Atlantic into New England. Are you buying the increased risk? Let's see what they got here. Let's see, I know I had that up originally. Here we go. Let's see what they're playing with here. Okay, so basically what I see here, I get what they're trying to do. You got some speed shear to deal with, so that's certainly going to be a factor. If there's going to be severe thunderstorms, I think they're going to be more towards east central Pennsylvania, where you have a stronger jet max setting up around the Great Lakes, so you're going to have a lot of enhancement there. Not so much for, I don't think, for the northern Mid-Atlantic. I think that's going to be delayed a little bit because I think the majority of the influence and the falling 500 millibar heights are going to be after peak period of instability in the atmosphere. So I like more central Pennsylvania and central New York. We'll keep an eye on it. I certainly can't rule out a rogue severe thunderstorm, but I think our primary impact is going to be the heavy downpours coming in with this system. What caused the unusual appearance of the small storms on Monday? I was outdoors and was able to watch from a distance, but they were very unusual looking. So basically what happened was a shortwave trough from New England dropped south through our region. Now what was supposed to happen was this trough drops through and produces some scattered cloud cover. A lot of the model guides had relative humidity around 25 to 40% at the mid-level. So I'm thinking, okay, a few clouds, no big deal, not much in the way of rainfall. But what happened was that because it was coming in from the Gulf of Maine and you had some additional tropical moisture from whatever was left over from Idalia, it led to more of a moist profile at the mid-levels and more instability in the atmosphere, which led to those scattered showers and thunderstorms. Time to bring out the Korean model. Yeah, I don't think so. I can't believe people are actually still using that. I didn't even know that was still running. That used to be such a big... The Korean model was a really big deal in the early 2000s because around this time period, again, remember a time when you had to dial up for internet and you had to rely on AOL. Okay? So you really had limitation of your model guides. You had the MRF, which is the precursor to the GFS. You had a somewhat European look, but it was really, really bad maps. You could barely make out what was being shown. And you had the Canadian in black and white maps. And let's see. And then you had the UK Met that came out. Then came the Korean, which was like, wow, a new model. But in reality, it really wasn't that good, but it was new. So everyone really focused on it. It's pretty much on par with the No Gaps, which is the Navy model that used to be used a long time ago that is discontinued. So yeah, gotta love those old models. I'm surprised someone didn't bring up the Brazilian yet. I'm sure that will show up sooner or later. Rob Allen asks, there's a few questions obvious on the topic of the day. Day one, would a Cat 5 create a disbursement of latent heat that creates a stronger block overall? That is the concern that we're going to be keeping an eye on. Oh, by the way, there is no Cat 6. Just so everyone knows, pass it along to TikTok, there is no Cat 6. Let's see here. 2, GFS ensembles is significantly southwest on 18Z. Yeah, what happened on the 18Z guidance is that, in fact, here, I'll just show you. Let's go to the 18Z guidance here. Let's see, I think it's this. And we'll go to... Okay, so there's our hurricane marching along. There's our ridge that gets enhanced. Now what happens is that the trough goes positive, but then it tries to pull some of the members further to the west despite a positive tilt here. So it's trying to cause the lowest 500 millibar heights to get pulled into the tropical low and connecting into one trough and then pulling it west. It's hard to pull that off when you have a positively tilted trough. It's a lot easier to pull that off when you have a negatively tilted trough, which is why the GFS ensembles is a little bit It has some of these errors. Now, if the model guidance, and here, let me pull up, instead of 500 millibar winds, let me do heights here, because that really shows up real nice. So there it is. It tries to get pulled into this trough here, which is a positive tilt. The reason why I says it works better with a negative tilt is that in this positive tilt, you have a lot of strong southwesterly winds here that should kick this straight out, okay, in this zone right here. Maybe a threat for, let's say, the Canadian Maritimes in this setup here. We're going to look at it, all right? So what it tries to do is it tries to connect the two. Now, that idea works better if this trough is like this, out ahead of it. Instead of this, if the trough is a little bit more negative, let's say it comes in like this or like this. Let me see if there's a way for me to draw that. Okay, let's see. Too bad I don't have a pen or something I can use. I could really use that. That'd be a good tool to use. Let me see if I have that. Because I'm trying to illustrate it, and sometimes it gets a little bit more difficult. And I don't want to use special effects. Last time I used special effects, I had a horn that went off for like 3 months. Okay, so let's see. Let's see if I can use the old chart here. Okay, so this is why all this is important, orientation. So here is the United States, and that, New Jersey, New England, Long Island. There's our islands out here. Puerto Rico, right? And here is our storm, right? Now, in this scenario, we're watching as this explodes, this increases the strength of the ridge. Now, because of the latent heat that develops here, it forces this ridge to become even stronger. So now let's do a big H here. It's a big mean H. And that would mean that your circulation would force our hurricane in this direction. Pretty well established, okay? That's pretty much understandable. Now the key here is this trough. You see that right there? If it's in this position here, all the winds come out in this direction. And so our storm, it could get close, but it gets kicked out. So those are pretty much the two primary tracks that we're seeing in the model guidance. If we see a negative tilted trough, which is the only thing that I'm really concerned of to get this thing to come further west to be a significant threat, what happens then is that this, let me erase this and this. In fact, we'll use a different color here. See if it stands out. Hopefully it works. If the trough is like this, or you get an upper level low like this, I don't know if that shows up very well, but go back. Like this, if we see this starting to show up here, then that pulls the winds in like this, which then would bring the hurricane in. I don't currently see that, but that is what would need to happen for us to get this to be significantly further west. Otherwise, all you have in this pattern is the storm gets close to the coast to create a lot of scare, create certainly a lot of wave heights and some enhanced surf and some coastal flooding, but it gets kicked out eventually because of the nature of our pattern. But if we get any type of upper level low to kick in to cause that negative tilt, well, then I'm going to have a nice test run of my generator. That's for sure in that scenario. But right now, I have nothing to support that evolution. And 3, let's see here. How about the Euro weeklies for the winter? I saw that. Yes, okay. I'm going to show it just because you guys deserved it after the previous winter. So let's see here. I know it's around here somewhere. Here we are. Okay, so here's the updated, and we'll do 500 millibars first. Let me. Yeah, let's zoom out to North America. If that happens, there's going to be an awful lot of snow lovers who are going to be very, very happy. Now, typically in El Niños, they start off slow. So, for God's sakes, please do not say winter's canceled just because December is warm or you don't have 10 feet of snow on the ground already. Okay? Because El Niños are known for starting out slow. But I'm also going to give you a warning here. While this looks beautiful, always remember with these patterns that if one little thing goes off, you don't actually get what you think you're going to get in terms of winter weather impacts. But yeah, I mean, if I was looking to forecast for a very active winter, I would certainly be very interested in seeing this evolution showing up, and it certainly would catch my eye, that is for sure. So we'll see how it plays out. We got a lot of time. But, for some of you snow lovers out there, I get it. It's been a rough couple of years, so that one's for you. Enjoy. If tropical wave behind Lee intensifies, which the environment seems to favor, would that help Lee get kicked out north and northeast? I'm not sure yet. That's a really good question and something that I'm still working on trying to figure out. I think that because it's going to be lifting up into the northern Atlantic, I think that it will have some influence on the ridge, but it also kind of cut it down. So it kind of depends on how strong that other tropical wave gets. After Hurricane Lee exits, how would that affect the pattern going forward? That kind of depends on the interactions we described. Premium membership fee is well worth it. Thank you. Significant flash flooding threat the next couple of days. In some spots, especially in northeastern Pennsylvania and the Poconos, Catskills, northwestern New Jersey. There's a good potential there for training rainfall, maybe about 2 inches of rain over a 5-day period. Not extensive flooding, but definitely something to keep an eye on. This mention about the 2,000-mile analysis maps is brought to you in part by Penn State eWall and Plymouth State Weather. Yes! God, I remember the Penn State eWall. I used to live on that website. That again, some of you younger guys, you have to understand you're in the golden age of meteorology information, right? Because the only model guidance I had was either Plymouth State and the Penn State eWall, which is basically like you kind of click on it. It's very, very rudimentary. And that was pretty much it. And that's what you pretty much had to survive on. Let's see what we got here on YouTube. Let's see here. And doing a little soft prep for Lee. Yes, good idea. Guys, that is a great idea. Look, do not get scared or worried about this storm just yet, but do as we have done. We are prepared for the fall and winter, as in power outages and stuff like that. We got our canned goods, we got new batteries, we got our flashlights, we're ready to roll. Regardless of whether we get a hurricane, a nor'easter, whatever. Now it's the time to prepare because we're heading into that season anyway. Here in Boston, Massachusetts, yeah, absolutely. Which scenario is more likely? I really, really think more likely because of the possibility of tilted trough. I think more likely this stays out in the Atlantic. But I can't let my guard down either. Point of impact along the coast. Judy, I'm not sure where the impact would be because there's far too many factors to determine. But as you know, as soon as I get an idea on that, if it should be a threat, then I will detail it. Will Lee have an impact on rough surf? Yes. No matter where it tracks, Lee's going to have a very significant impact on rough surf and coastal flooding. Definitely. It's going to enhance the wave heights, going to have strong rip tides. All of those factors are definitely going to be in play. When will we verify the Lee forecast? I'm looking at Monday. It's Wednesday now. I know it's a little bit far out, but hear me out. By the time we get through this weekend, we'll know exactly how strong Lee has gotten and the expansiveness of the hurricane, which means we got a really good idea of where the ridge is in terms of strength and location. So once we get those two factors, at the same time, the trough that we're watching diving into the Tennessee River Valley will be well sampled. So then at that point, we should have all the players on the field to make an accurate forecast that's going to lock in. Look like the Sandy map. No. Yeah, okay. So, all right. I'm going to touch on Sandy real careful, okay? Every time there's a hurricane anywhere near the East Coast, Sandy's brought up. I want to be careful not to downplay this. But understand also, the Sandy situation was such a perfect combination of features that is very difficult to have happen again. With that said, there is a reason why I'm very concerned about any type of upper level low feature being shown in any model guidance cutting off around the Tennessee River Valley. It is a huge warning sign for me and something I watch out very carefully when forecasting for any hurricane or storm tracking around the western Atlantic and around the East Coast. Oh, congratulations on your retirement, Chris. I know snow plowing cannot be fun sometimes. Is anyone assessing that Lee caused the cyclone in Brazil? No. Anything that happens in South America has no impact on North America or the North American pattern, and the reason why is because of the Coriolis effect and the equator. You're pretty much separated in terms of wind patterns. So anything that's happening in the southern hemisphere really doesn't have a direct impact on the northern hemisphere from a synoptic level. Let's see here. Unfortunately, I don't know. I'm trying to learn Spanish, but it's really not good. So I'm not going to even try to struggle that. My windows are boarded already. Well, that's pretty. I think so, but hey, you do you. Let's see here. Anything tropical going on in the Western Pacific? I honestly have not been on top of the Western Pacific. Let me see if there's anything. And that's just the truth. I've just been so swamped with everything else. I haven't really looked at the Western Pacific all that much. But let's see here. There certainly appears to be a lot of activity. We got a tropical storm passing to the east of Japan. Let's see here. That's around Mexico. Nothing that is really impressive. Yeah, nothing that is really impressive or that would impact the weather pattern. Sandy had a big negative NAO already in place. That's true. That is true. It did. And then the interaction of the storm slowed down Sandy enough to get captured and to catch the storm. So I would say the massive volcanic eruptions in the southern hemisphere are an exception to the southern hemisphere. Well, see, that's a geological factor. Okay, so in terms of geological factors, if you have a volcano that erupts in, let's say, the southern hemisphere near the equator, and it reaches the stratosphere, that eventually impacts the whole globe. No doubt about that. But in terms of an individual storm, because of the way that the wind patterns work out, it's really, really hard to make a connection between what's happening in the southern hemisphere to what's happening in the northern hemisphere. Which is why when some people start to pull out, what's happening in the Antarctic with with the polar vortex there, it's not really a good idea to use that data. A lot of people try to use that, and what I say to them is, don't just look at the statistics. What I want you to do is, what is the physical parameters impacting the pattern? And the reason why I say that is because I know for a fact that the physical parameters are so separated that it doesn't really have a direct impact on what's evolving here. So that's why I always say that. It's a very questionable process. Let's see. So far, we've gotten some great questions. Did Sandy have the upper level low in the Tennessee Valley? Yes, it did. In fact, what happened with Sandy is that there was an upper level trough and upper level low that went into a negative tilt that captured Sandy. So Sandy was out here, the upper level low was out here, and the upper level low captured Sandy and pulled it back towards the New Jersey coast. Now, what happened in that process, and what's made this storm really unique, is that Sandy was a weakening tropical system. that was stalling out over the Western Atlantic because of the negative NAO block. So what happened is that the upper level low captured Sandy and pulled it, literally slingshot it right into the New Jersey coast while it was transitioning from a tropical system to an extratropical system. And because of that, it led to a lot of issues in terms of what is this storm, how do you handle the insurance, all that stuff, because it was a transitioning storm. So this is why we have more and more details about subtropical storms, because that's essentially what it was transitioning into. I don't want a disaster. Yeah, neither do I. I feel bad for this person typing a lot of Spanish because I have no idea what the heck they're saying. Another problem with Antarctica is that there are no land masses outside of it for a good long distance from the surface all the way up. Yep, that is true. Absolutely. Do we have anything on X marks the spot?
Nope. No questions, just a lot of viewers.
All right, good deal. We do have a lot of viewers, and I want to say thank you to everyone watching on YouTube, on X, and of course my premium members. Just a little bit of a plug for me. I guess it's a good idea to put this in. I was told that one of the ways that I could advertise is to actually show where to subscribe. So I would promise one of the people who helps me out running the website that I would do this. So if you're interested in subscribing, right, it certainly helps what I do. It allows us to grow. It provides me to add great content like Tom Moore Something More, where we do historical discussions, which you can find right under the public map right here. Also, I added the severe alerts up here. But if you zoom down here, this is where you can find all the stuff with Something More. And if you're interested and you want to get a little bit better content every day about what's happening and get the latest details, I'm sure a lot of the premium members will tell you that, hey, look, it's a great value right now. $11 a month or $80 a year, sometimes $30 seasonal. And of course, that will be increasing as we go forward. So I made a promise that I would actually share this and show this to let you guys know these are the values. And as a premium member, this is when you go to the premium dashboard. You get all this content, videos every day, all sorts of analysis on what to expect. And of course, asking questions anytime. So, do we have any additional questions, hon?
You just got a wave that came through on YouTube.
Oh boy! All right, we got a wave. Is it in English? That's the question. Let's see here. Yankees start winning again as they start playing the kids. Hey, same thing with the Mets. That's all I can say. And let's see, what do we got here? Holy smokes, it really is active here.
Yeah.
Woo! X marks the spot. Yep. January 2021 eruption went 38 miles high into the mesosphere. Yes. All methane water to dust ice crystals. 10 years for methane to break down to water are concerned. Yeah, they're still working on that. I'm definitely, let me go here. It is something I'm studying very carefully. And the problem with that volcano, especially, is the introduction of the water vapor. I'm trying to understand how that's impacting the QBO evolution and the state of the stratosphere and the interaction between the different masses in the stratosphere and troposphere. It's very complicated. There's a lot of chaos theory now because there's a lot of chaos going on in the atmosphere now. It was harder when it first started because everything was in a state of changing. It's kind of stabilized a little bit. So now it's... The reason why the Synchronous forecast is a little bit more difficult is because It's not as simple as saying, well, El Nino equals this, or warm stratosphere equals that. Now there's a huge X unknown, and we as atmospheric scientists have to figure out how is that factor interacting with all these other moving pieces in the atmosphere. And it's very dynamic, and in a way it's like an art form, because you can't just say, well, we're going to put in this calculus and that's it. I wish the atmosphere worked that way, because then forecasting would be easy. We just throw in some math equations, done. It's not that simple. So what you have to do is study what's going on in the water vapor, study the evolution and the pattern here, take what you know in terms of physics and all the equations and all the meteorological laws, and combine all of that, and then work out a theory. When you could do that, that's when you start to nail down the pattern. But it is very difficult, and the only way to succeed is to constantly fail and get back up until you get it right. I want to say thank you. No, thank you. This reminds me of Gloria in 1986, came close to Jersey Shore and went into Long Island. It's certainly a possibility. I think it's going to curve east for now, but definitely a possibility. Wow, we are really busy. We love you, Steve, and I love you guys. I really appreciate you guys. Have no idea. I get to live my dream because of this, you know? I gotta learn Spanish. I have no idea what the heck he's saying.
You and I both failed miserably trying
Yes.
to learn Spanish.
Look, I've already butchered the English language, so now you're going to ask me to butcher the Spanish language. That's going to be even more fun. Interesting, great topics. Are you ever going to get your PhD so we can refer you as doctor? I probably would not. What I am working on.
Find the time.
Yeah, right. That's the other thing too. Maybe if I get one, like, as an award or something, like how they do that.
Honorary PhD.
Yeah, honorary PhD. But what I am going for is my CDM from the American Meteorological Society. I'm studying my ass off on that. I want to be the first one to get it, because that'd be really cool. Be the first certified digital meteorologist from the American Meteorological Society. I would take that more as a doctor. I have a lot of respect for guys who go for their PhDs, but they're kind of a different cat in terms of meteorology, in the world of meteorology. A lot of PhDs, they are very, very much into theory and not so much into operational forecasting. I love operational forecasting. I think the guys who work on theories, and guys like Dr. Judah Cohen, are amazing, but they're not me. And we all have our benefits, and our strengths and our weaknesses. Okay. Good luck. You could do. I really appreciate that. And wow, it is almost 9 o'clock. And so I think for tonight, I hope I answered a lot of your questions. Of course, there's a lot that has to be worked out, and a lot that we're going to work on. Unfortunately, I wish I was up on what happened in Brazil. I really don't know specifically. I know this could have been covered already, but what scenarios do you think could happen? Okay, so as long as we have a positively tilted trough, I think this stays out in the Atlantic. But it's going to get awfully close, and it's going to scare a lot of people, and there's going to be a lot of hype, and you can expect the news to have a very dramatic music and all that stuff. But as long as there is a southwesterly upper level wind set up on the East Coast, this thing's getting kicked out. But it will cause enhanced wave heights, coastal flooding, and a strong riptide. So I'm going to put that there. If we see any inkling of a negatively tilted trough, which I'll be keeping an eye on, well, then things are going to get a lot interesting around here. So we'll keep an eye on that. Forecast for Cowboys versus Giants. A lot of hearts broken. But I do expect scattered showers. I think, obviously, they're going to play, but definitely a wet field. I would not be surprised to get a wet field. And some showers to worry about. I wonder how the Giants are going to. I'm curious how the Giants. Of course, I'm a Chiefs fan, so I'm excited about the Chiefs, seeing how they do. But I'm curious to see how well the Giants and Jets do. There's certainly a lot of hype around here for them, so we'll see. Well, that is our chat for tonight. It is 9 p.m. I'm about to lose my voice, so there we go. Just a little heads up. Tomorrow, no videos, but I will have text updates. And then we go back to videos on Friday, most likely with a public premium discussion. So just wanted to put that out there. That's it for tonight. Thank you for joining. I really, really appreciate it. And as always, stay safe out there.